There is a wall in Peru that modern engineers cannot build. Not won't, not haven't tried, cannot. The machinery exists, the materials exist. The budget theoretically could exist. The wall does not. It has been standing for over 500 years. The stones weigh 120 tons. They were fitted without mortar, without metal tools, and without the wheel. The joints between them are tighter than the tolerances achieved by modern stonemasons using diamond-tipped equipment and laser measurement. 5 centuries of Andean earthquakes have not moved them 1 millimeter. We know who built the pyramids of Giza. We know who built the Colosseum. We know who built Stonehenge, or at least we have a civilization to assign it to. For Sacsayhuamán, we have something else. We have the people who lived inside the empire that supposedly built it. And we have what they said when a Spanish soldier asked them in 1553 who was responsible for the walls above their city. Every textbook assigns Sacsayhuamán to the Inca Empire. The Incas said it wasn't theirs. That testimony was written down. It is in a published document, available in the original Spanish, sitting in archives that have been open to researchers for nearly 5 centuries. And in 1997, a civil engineer at the University of California, Berkeley, ran the precision measurements on those joints and published a number that the official construction account cannot produce, even with modern tools. That number is in Act 4, and it changes what the testimony means entirely. In 1997, Jean-Pierre Protzen of the University of California, Berkeley, published a technical analysis of Sacsayhuamán's stone joints in the Journal of the Society of Architectural Historians. His finding was specific. The contact surfaces between adjacent blocks had been finished to a tolerance of less than 5 millimeters, across stones weighing between 50 and 120 tons. That number requires context. 5 millimeters is the thickness of a credit card. Protzen wasn't measuring decorative facing stones. He was measuring the internal fit of multi-ton limestone and andesite blocks that had been quarried, transported, shaped, and placed without mortar, in a mountain environment at 3,700 meters above sea level in the 15th century, by a civilization that had no iron tools, no steel, and no wheel for transport. Modern stonemasons working with diamond-tipped equipment and laser measurement achieve tolerances of 3 to 4 millimeters on precision contracts. The Inca masons were 1 millimeter behind, without the equipment. What makes Protzen's analysis structurally significant isn't the number itself. It's what the number eliminates. A tolerance of 5 millimeters cannot be achieved by trial and error on 120-ton blocks. You cannot reposition a 120-ton stone 6 times until it fits. The shaping had to be calculated before placement.
Enjoying the story so far? Subscribe to Untold History and keep discovering the past they never told.
That requires measurement instruments. Protzen's paper documents the precision. It does not explain the instruments. No instrument cache has ever been found at any Inca quarry site. The standard academic response has been to propose that the Incas used harder stones as hammers, a technique called percussive dressing, combined with abrasive sand to gradually grind surfaces to fit. Protzen himself tested this method at the quarry site of Cachicata. He could replicate the surface texture. He could not replicate the tolerance. The grinding method produces irregular surfaces. Sacsayhuamán's joints are not irregular. They are convex on one face, concave on the adjacent face. A mirror geometry that required both blocks to be shaped in relation to each other before being separated and stacked. That is not a primitive technique. That is a manufacturing logic. Protzen published this. The paper is peer-reviewed. It has been cited in subsequent archaeological literature without being refuted. It has also never been resolved. The precision exists. The tools don't. And then there's Cieza de León. The official story of Sacsayhuamán begins with a name. Pachacútec, the 9th Sapa Inca. The ruler who, according to every major archaeology textbook, ordered the construction of the fortress complex above Cusco sometime around 1438 AD. The same decade he expanded the Inca Empire from a regional kingdom into the largest political entity in the pre-Columbian Americas. The standard account is impressive on its own terms. The Inca Empire at its peak controlled a territory stretching 4,000 kilometers along the Andes, from what is now southern Colombia to central Chile. It administered this territory without writing, without money, and without the wheel, using a system of runners, knotted rope records called quipus, and a labor tax called mita, the obligation of every adult male to contribute a fixed period of work to the state each year. Sacsayhuamán, under this account, was the product of that system operating at maximum scale. Estimates from archaeological surveys suggest between 20,000 and 30,000 workers over a construction period of approximately 60 years. The stones were quarried from sites across the Cusco Valley, shaped at the quarry, transported overland on wooden sledges and reed rollers, then lifted into position using earthen ramps and lever systems made from timber. It is a story of organized human effort, of an empire that moved mountains because it could organize enough hands. The quarry is 35 kilometers away. That detail appears in every account. It is cited as evidence of Inca logistical capability, the ability to coordinate transport across difficult Andean terrain. What the same accounts do not calculate, as a rule, is the time that transport would have required at the scale the stones demanded. That calculation exists. It was done. The number it produces is the detail no textbook lingers on. By the mid-15th century, Cusco had become the administrative and ceremonial center of the empire, a city the Spanish would later describe as more impressive than anything they had seen in Europe. The temple complex of Coricancha, plated in gold, stood at its center. Above the city, on the hill of Sacsayhuamán, the fortress temple rose in 3 massive terraced walls, zigzagging in a pattern that maximized defensive angles and, as engineers would note 5 centuries later, distributed seismic stress across the structure rather than concentrating it at any single point. The Incas were sophisticated builders. No serious archaeologist disputes that. What the official account requires you to accept, without dwelling on the arithmetic, is that sophistication scaled linearly with manpower. That enough workers and enough time explains every feature of what was built. There are 3 things wrong with that assumption. The first one takes 30 seconds to explain. Can't explain. That's the phrase engineers keep using. Not difficult to explain, not yet fully understood. Can't. As in, the mechanism required by the official account does not produce the result we are measuring. That is a different category of problem. Can't explain. That's the phrase engineers keep using. Not difficult to explain. Can't. The arithmetic starts with the largest stones. The biggest blocks at Sacsayhuamán weigh between 100 and 120 tons. The quarry at Cachicata, the primary source for the andesite used in the upper walls, sits 35 kilometers from the construction site across broken Andean terrain with an elevation change of several hundred meters. Moving a single 120-ton stone on wooden sledges over that distance, using the rope and lever technology the official account proposes, requires a sustained pulling force that engineering calculations place at between 2,400 and 3,000 workers per stone, operating in coordinated shifts across terrain that cannot physically accommodate that number of people on a single rope line simultaneously. The logistics don't fail at the muscle level. They fail at the geometry of the road. In 2008, a team of civil engineers led by Vince Lee published load-bearing calculations in the Journal of Archaeological Science, examining Inca stone transport methodology. The study confirmed that the proposed sledge and roller system was physically viable for stones up to approximately 15 tons. Above that threshold, the method requires infrastructure, graded roads, reinforced surfaces, lateral anchoring systems, for which no archaeological evidence exists on the Kachikata route. The 120-ton blocks moved anyway. They are sitting at Sacsayhuamán. But the second problem is not the transport. The second problem is the joints. Protzen established the tolerance in 1997. What his paper did not fully address, and what subsequent analysis has developed, is the geometric logic of the convex-concave fit system. Each stone at Sacsayhuamán was not shaped to a flat surface. It was shaped to interlock with its specific neighbors, a three-dimensional puzzle in which every block is unique, shaped in relation to the blocks above, below, and beside it. This means the shaping sequence had to follow the placement sequence. You cannot shape block 47 without knowing where blocks 44, 45, 46, and 48 will sit. Which means the entire wall was designed, completely in 3 dimensions, before a single stone was placed. That is not a property of incremental construction. That is a property of pre-calculated design executed at scale. Modern seismic engineers recognize the system immediately. The convex-concave interlock distributes lateral stress across the joint, rather than concentrating it at the contact edge. When the ground moves, the stones shift microscopically and resettle. They do not crack. They do not separate. Cusco has experienced major earthquakes in 1650, 1746, and 1950. In each event, Spanish colonial buildings constructed directly on top of or adjacent to Inca foundations collapsed. The Inca walls did not. The technique works. It worked before the engineering principle was formalized. And the third problem is not engineering at all. It is a document. Written in 1553 by a Spanish soldier who had no reason to invent what he recorded, and every institutional reason to suppress it. A man who asked the Incas directly who built the walls above Cusco, and wrote down what they said. There's a document, written in 1553. It records something the Incas said that no archaeology textbook quotes in full. Pedro de Cieza de León arrived in Peru in 1547. He was 22 years old, a soldier in the Spanish colonial administration, and he spent the next 6 years traveling the length of the Inca Empire, recording what he saw and what he was told. His Crónica del Perú, published in Seville in 1553, is one of the most cited primary sources in Andean archaeology. It is Tier 1 by any academic standard, a first-hand account written within living memory of the conquest, by a man who spoke directly with Inca administrators, curacas, and elders who had grown up inside the empire. Cieza de León visited Sacsayhuamán. He measured it. He described it. He recorded his own reaction, that the stones were so large and fitted so perfectly that he could not understand how human hands had placed them. Then he asked. He asked the curacas, the regional lords who administered Cusco under Spanish oversight, who had built the fortress above their city. The answer he recorded in chapter 51 of the Crónica is precise and unambiguous. The curacas told him that Sacsayhuamán was not built by the Incas. It was built, they said, by people who came before them, a people they referred to as having possessed knowledge and capabilities that the Incas themselves did not have. The Incas had added to the complex, they had maintained it, but the original construction, the 3 massive terrace walls, the precisely fitted megalithic blocks, predated the empire that claimed it. Cieza de León wrote this down. In 1553, in a book that has been continuously available to Western scholarship for nearly 5 centuries. It has been cited hundreds of times in Andean archaeological literature. The specific passage, the Curaca's testimony about pre-Inca construction, is quoted in fragments, contextualized as mythology, or footnoted without analysis. It has never been the subject of a mainstream archaeological investigation. And this is where it gets interesting. Cieza de León was not the only Spanish chronicler to record this testimony. Juan de Betanzos, who married an Inca noblewoman and spoke Quechua fluently, recorded in his Narrative of the Incas, 1557, that Pachacutec, the ruler credited with building Sacsayhuamán, ordered the construction of a fortress on a site that already had structures on it. Betanzos describes Pachacutec surveying the existing stonework and ordering new construction around and above what was already there. 2 independent Spanish sources, written within a decade of each other, both describing the same thing: Inca construction activity at a site with pre-existing megalithic stonework. The academic response to this has been consistent for decades. The chroniclers were recording Inca mythology, not history. The pre-Inca builders are assumed to be a narrative device, a way for the Incas to explain construction achievements that exceeded their own self-understanding. That interpretation is possible. It is also unfalsifiable. What is falsifiable, what has been tested, is the engineering. And the engineering produces a specific problem that the mythology interpretation does not resolve. If the Incas built everything at Sacsayhuamán, the tools required for the precision documented by Protzen in 1997 should exist somewhere in the archaeological record of the Inca Empire. They don't. No iron chisels, no steel measuring instruments, no evidence of the pulley systems that the transport calculations require. The absence is not a gap in the record. Inca material culture is extraordinarily well documented. The tools used for known Inca construction projects, terracing, road building, smaller ceremonial structures, are present in museums across Peru and in dozens of archaeological sites. The tools required for Sacsayhuamán are not among them. In 1553, a Spanish soldier sat across from the men who administered the greatest empire in the Americas. He asked a simple question: who built this? And the answer he received, from the people whose civilization is credited with the construction, whose empire's greatest achievement supposedly stands on that hill, was, "We don't know." Not, "We built it and the knowledge was lost." Not, "Our ancestors built it and the records were destroyed." We don't know who built it. That answer is in the document. Chapter 51. Published 1553. Available in the original Spanish in the Biblioteca Nacional de España. Translated into English by Harriet de Onis in 1959. Published by the University of Oklahoma Press. It has been sitting there for 471 years. The Curacas of Cusco, in the decade after the conquest, did not claim Sacsayhuamán. We claimed it for them. Because the alternative, that a civilization we cannot identify, using techniques we cannot replicate, built a structure that has survived 5 centuries of Andean.
Enjoying the story so far? Subscribe to Untold History and keep discovering the past they never told.
Seismic activity requires a revision of the timeline of human capability in the Americas that no existing academic framework is currently equipped to absorb. So the testimony stays in the footnote, and the official story stays on the wall. In 1950, a major earthquake struck Cusco. It measured 7.0 on the Richter scale. It killed approximately 100 people, destroyed thousands of structures, and left large sections of the colonial city in rubble. Churches built by the Spanish in the 16th and 17th century, some of them standing for 300 years, collapsed. The walls of Sacsayhuamán did not move. That is not a metaphor. That is a structural engineering outcome. The same seismic event that brought down Spanish masonry constructed with mortar, iron reinforcement, and centuries of accumulated European building knowledge left the dry stone megalithic walls above the city functionally intact. The Spanish had built on top of Inca foundations in several locations across Cusco. After the 1950 earthquake, those foundations were still standing. The colonial structures above them were not. The boundary between what survived and what collapsed followed, in several documented cases, the exact line between Inca stonework and Spanish construction. This is not archaeology. This is civil engineering data from 1950, and it has a direct application today. The convex-concave interlocking joint system documented at Sacsayhuamán, the system that distributes seismic lateral stress across contact surfaces rather than concentrating it at edges, is now a recognized principle in earthquake-resistant construction. It appears in Japanese traditional timber architecture, in modern base isolation systems, and in the design guidelines of the International Building Code for high seismic zones. The principle was not derived from Sacsayhuamán. It was rediscovered independently. Because the structure at Sacsayhuamán was classified as a cultural monument, not an engineering resource, its construction method was filed under archaeology, under the assumption that it was a product of primitive labor at scale, rather than under structural engineering, where the seismic performance data would have demanded a different conversation entirely. That classification has consequences. When the 2007 earthquake struck the Ica region of Peru, 8.0 magnitude, 519 dead. Engineers surveying the damage noted again that pre-Columbian stone structures in the affected area outperformed modern reinforced concrete construction in several locations. The observation was published in damage assessment reports. It did not produce a research program into pre-Columbian building methodology. The pattern is consistent. The anomaly is documented. The performance is measured. The institutional response is to file it under heritage and move on. There is a reason for that. If the engineering at Sacsayhuamán is accepted as the product of a civilization that predates the Incas, a civilization with design capability, precision tooling, and structural knowledge that the official timeline of Andean prehistory does not accommodate, then the timeline requires revision. And timeline revision in archaeology is not a technical adjustment. It is a career-ending proposition for the researchers whose published work depends on the existing chronology. The walls perform better than our buildings. We built them into a museum. And the question Cieza de León asked in 1553, the one the Curacas answered with, "We don't know," has not been asked again by anyone with institutional funding and a peer-reviewed platform. The walls were always there. We just kept looking at the wrong ones.